Good morning, one and all. My name is Andur Garo from EC Department, Vignan Nirla. Today we'll discuss the properties of ROCs. These properties of ROCs will be discussed based upon the two infinite duration signals and finite duration sequences. As we have already seen, that Z transform of A power n U of n will be given as Z by Z minus A for mod Z greater than A, and minus A power n U of minus n minus 1, whose Z transform as Z by Z minus A only, but mod Z will be less than A. Mod Z will be less than A. Now, based upon these properties, we can define the properties of the ROCs. First, if we consider that right-sided sequence as some x of n is equal to 2 power n, that's 1 by 2 whole power n u of n plus 1 by 3 whole power n u of n. As this is u of n, it's called as a right-sided sequence. For this right-sided sequence, the Z transform as Z, x of Z is equal to Z by Z minus 1 by 2 plus Z by Z minus 1 by 3. Then here the mod Z will be greater than 1 by 2. Here also the mod Z will be greater than 1 by 3. Therefore, the entire ROC is with the 1 by 2 pole, one circle, and 1 by 3 pole, another circle. As 1 by 3 is lesser than 1 by 2, we'll have like this. First case for the mod Z greater than 1 by 3, that means outside the inner circle, and the mod Z greater than 1 by 2 means outside the outer circle. Therefore, it will be given by, therefore the common ROC will be nothing but it is greater than 1 by 2. The greater than 1 by 2. That mod Z greater than 1 by 2 is your ROC. That is for a right-sided signal, the ROC is right of the rightmost pole. Rightmost pole. Right of the rightmost pole. This is the left of the most pole. This is right of the rightmost pole. ROC is the right of the rightmost pole. Right of the rightmost pole. Similarly, if we take the left-sided sequence, this is the first property of the ROC. Second property is right-sided sequence, and this is an infinite duration only, because the u of n runs from 0 to infinity. Therefore, it is an infinite sequence. Next one has an infinite left-sided sequence. Infinite left-sided sequence. Then its ROC is left of the leftmost pole. Left of the leftmost pole. The ROC is left of the infinite left-sided sequence is left of the leftmost poles. How it is, we'll see. Further, consider the example like this: 1 by 2 whole power n u of minus n minus 1 minus 1 by 3 whole power n u of minus n minus 1. Because of u of minus n minus 1, here also u of minus n minus 1, it is being considered as a left-sided sequence, because the n varies from minus infinity to minus 1. Therefore, corresponding Z transform x of Z is, it is a Z by Z minus 1 by 2. As there was no minus at here, in the original formula we'll have minus, but here minus is not there. That's why keep a minus at here. But this is also in the same form, but we'll have minus at here. Therefore, take the plus Z by Z minus 1 by 3. This is the Z transform. But the ROC is mod Z less than 1 by 2, and here also the mod Z will be less than 1 by 3. Therefore, the ROC for this one as one pole, another pole, 1 by 2, 1 by 3. The mod z will be less than 1 by 2 means this one ROC, and the mod z less than 1 by 3 means outer circle inner part will be our ROC. Therefore, the common ROC is nothing but this particular one, that mod z less than 1 by 2. That is, ROC is left of the leftmost pole means this one, like this, left of the leftmost pole. That is interior, or we can write like this, ROC is exterior to the outer circle, exterior to the outer circle, that mod z greater than 1 by 2. But here also we can write similar fashion like this, that is interior to the inner circle, that mod z less than 1 by 2 this case. If it is combined, the case of that is two-sided sequence for the two-sided infinite sequence, that is x of n will be given like this. We are combining both forms, that's 1 by 2 whole power n u of n and minus 1 by 3 whole power n u of minus n minus 1. As we are been combining both of them, therefore its z transform has been given as x of z is equal to z by z minus 1 by 2. And here also minus has been present, it will be given by z minus 1 by 3. For this particular one, the z transform as mod z greater than 1 by 2, and the second one for the mod z will be less than 1 by 3. If you draw the graph of that particular one, this 1 by 3 and this is 1 by 2 circles. First one, mod z will be greater than 1 by 2 and mod z will be less than 1 by 3. Then there was no ROC, there is no intersection. One is this one part and another one is this one. Mod z less than 1 by 3 and mod z greater than 1 by 2. There was no intersection region, hence no ROC, no Z transform. This was the case for, that's 1 by 3 will be less than 1 by 2. If we take that, reverse the process, that's x of n is equal to some 1 by 3 whole power n u of n and minus 1 by 2 whole power n u of minus n minus 1. We'll get the solution and its Z transform. If we take the signal like this, that is x of n is equal to 1 by 3 whole power n u of n minus 1 by 2 whole power n minus 1 minus 1. Then its Z transform as z by z minus 1 by 3 plus z by z minus 1 by 2. Here there is mod z greater than 1 by 3 and here mod z less than 1 by 2. Therefore its ROC as here we'll have one circle, at 1 by 2 we'll have another circle. Therefore intersection region is nothing but this one. That means it forms like a ring. The ROC is a ring in Z plane bounded by the poles. Ring in the Z plane bounded by the poles. When this is the case of 1 by 3 will be less than 1 by 2 and properly taking this particular one values. Otherwise it does not, in some cases we will not have the ROC as well as its Z transform, but in a particular case we can get its Z transform by showing this particular example. Okay, And similarly, that is the third point. What is about the fourth point is, if we take our x of n as a finite right-sided sequence, finite right-sided sequence, that's the fourth one. For example, we are considering it as a sequence, finite now, that's why 1, 2, 3, minus 1, minus 2, like this. Right-sided sequence when this for n is equal to 0, 1, 2, 3 and 4. As it is only a finite, from n varies from 0 to 4, whose values as 1, 2, 3, minus 1 and minus 2. Therefore, arrow mark indicates always the n is equal to 0. If there was no arrow mark, we'll start with the n is equal to 0 itself. That is x of n. Similarly, this particular x of n and corresponding z transform as x of z is equal to summation n varies from minus infinity to infinity x of n z power minus n, and the summation n varies from 0 to 4 x of n z power minus n. N is equal to 0, x of 0 z power minus 0 plus x of 1 z inverse plus x of 2 z power minus 2 plus x of 3 z power minus 3 plus x of 4 z power minus 4. Put n is x of 0 as 1, 2, 3 like that. 1 into z power 0 means 1 plus 2 z inverse plus 3 z power minus 3. Minus 1 into z power minus 3 minus 2 into z power minus 4. This is x of z. As when we put z is equal to 0, our x of z will be infinity. Therefore, at the infinity means the x of z is infinite. That means it is not defined. Therefore, our ROC is the entire z plane except at z is equal to 0. That is the point. For a finite right-sided sequence, the ROC is the entire z plane except at z is equal to 0. Similarly, if you take our x of n, I am taking it the same values, but I am keeping the arrow mark at here. That means here the n is equal to 0. Before the values, the n will be negative, minus 1, minus 2, minus 3, minus 4 like that. Therefore, it will becomes it's a finite left-sided sequence. Left-sided sequence. For the finite left-sided sequence is our fifth point. What happens to its ROC? We'll see it by simply taking its z transform. X of z as summation n varies from minus infinity to infinity x of n z power minus n. Put that n is equal to minus 4 to 0 x of n z power minus n x of minus 4 z power minus 4. Minus of minus 4 means it's a plus 4. Then x of minus 3 z cube plus x of minus 2 z square x of minus 1 z plus x of 0 into z power 0. Substitute the values. X of minus 4 value as 1, that's why z power 4 plus 2 into z cube plus 3 into z square minus 1z minus 2, that's all. This is nothing but our x of z. That's it. For this x of z, when we put z is equal to infinity, directly the x of z will be infinity. Therefore, its ROC is that except that the infinity point, remaining values will be our ROCs. That's ROC is the entire z plane entire jet plane except at z is equal to infinity. That is your ROC. Similarly, the next point as if you take the x of n as like this 1, 2, 3, I'm taking the same values, but the position of the n is only changed. Now I am fixing the n is equal to 0 at the center, because the arrow mark indicates that n is equal to 0 is the center. Next, n is equal to 1, n is equal to 2 here, n is equal to minus 1, n is equal to minus 2. Therefore, its z transform as x of z as summation n varies from minus 2 to 2 x of n z power minus n. Then x of minus 2, z of minus 2 is z square, x of minus 1 z plus x of 0 plus x of 1 z inverse plus x of minus 2 z power minus 2. Z power minus 2. I substitute the values now. For n is equal to minus 1, its value as 1. That's why z square plus 2z plus 3 minus z power minus 1 minus 2z power minus 2. As we have the z power minus 2's negative values as well as z power values, this x of z will exist except at z is equal to 0 and z is equal to infinity. Okay? Hence its ROC is being given as ROC is entire jet plane except at z is equal to 0 and z is equal to infinity. That is the sixth point. This is the sequence called as the finite two-sided sequence. Finite two-sided sequence. It's a finite two-sided sequence. The ROC is the entire jet plane except at z is equal to 0 and z is equal to infinity. These are the 6 points. And similarly, the next properties of ROC is as the ROC, the 7th point as ROC does not contain any poles. Does not contain any poles. Next, the ROC does not contain any poles. The ROC of an LTI stable system contains the unit circle. Contains the unit circle. For a particular ROC of an LTI stable system, that's only the unit circle. That's below the unit circle or interior to the unit circle is 0. If we have the ROC, then the system is said to be stable. If ROC is included to the unit circle, it is marginally stable. If the ROC is outside the unit circle, then the system is said to be called as unstable. Okay? And the 9th one as the ROC of a transformation, ROC of an LTI stable system contains the unit circle. Then ROC of the corresponding ROC of impulse signal or the impulse sequence is entire jet plane. Entire jet plane. Why? Because the delta of n whose jet transform is 1. There is no jet, therefore the entire jet plane is your ROC. That is the properties of the ROCs.